Hey everyone, Charles Johnson, lead trainer and technical engineer at Lynxspring, and today we're going to talk about relays, more specifically relays that require integration. Functional Devices was very kind enough to donate two BACnet relays to me. One is BACnet MSTP and one is BACnet over IP. I'm going to go ahead and bring these into one of our Edge 534 devices to show you that integrating these things is actually quite straightforward. Relays are great as far as these kinds of relays. They're great to use in situations where you need to pick up some remote points without need to buy an expensive controller. So these are a more cost-effective solution. And I like using the word solution because that's what we need to provide to customers. And I'm not talking about just Lynxspring partners. I'm talking about any kind of controls contractor. Sometimes when we think of a solution, we think of just a controller, but really it is not only the controller, but any other devices that we may have. This is not limited to even things such as relays. Like, for example, Thermocon has a bunch of sensors that can be wireless, that can go to a BACnet gateway and brought back to back to a system. You can think of LoRaWAN or MONIT. Something that we use MONIT sensors. We have a MONIT controller, but those are types of solutions that we can offer to our customers. So let's go ahead and get into how to integrate a BACnet relay, specifically for functional devices. Well, the first thing that we're going to need is we're going to need the cut sheet, right? We don't know what relay this is here, and so I'm going to go ahead and go to ye old web browser here, and I'm going to go to Google Chrome. And I'm going to go to functionaldevices.com. Now, when I go to functionaldevices.com, we see the building automation and lighting control. So know that we actually have quite, Functional Devices is quite a robust company that offers an array of devices for people. So primarily, we're going to stick with the building automation. And remember, RIB actually stands for Relay in a Box. And under the RIB, we have the intelligent field devices. So we have the Modbus, we have the BACnet, and we have Wi-Fi. Today we're going to stick with BACnet. And the relay that I have in particular is this RIB MNWLB-7-BC. So this is actually for a fan safety circuit. Typically, this is actually smoke rated. It's a safety circuit mode, and that's the factory default here. And 7 means that we have 7 binary inputs. So typically, this is going to be used for some kind of alarm conditions. So when they operate and function, binaries inputs 1 through 6 are actually closed, and then then the relay will actually close if any of those close there. But I'm just going to show you how to actually control them through BACnet specifically. But I'm going to need a few things here. So I'm going to go and download the data sheet. And as I download the data sheet, I want to know first, more importantly, I need to understand what the BACnet settings are. So you'll see here the second page gives us the pretty much the wiring diagram that we would want to follow out of the box, again, for your fan safety circuit that you have here. So we've got some low temp alarms, high pressure alarms, smoke alarms, etc. Now, here we can see that we have our 7 inputs here. We can actually choose how we want to set them up. In addition, we can override our relays to override relays on or off, or automatic control. We have our 24-volt power, which can accept both 24 volts AC or DC. And then here we have the BACnet MSTP reference, which is our communication terminal, and our addressing switches. So both the baud rate and the MAC address, or the physical address of the relay. 1 through 7 on the terminal, on the dip switches here, it's actually binary. So 1 is 1, 2 is 2, 3 is 4, 4 is 8, 5 is 16, 6 is 32, and 7 is 64. Then we have the baud rate here, 8, 9, and 10. So if 8's the only one up and 9 and 10 are down, then it is 76.8 and so forth. So how do I know that? Well, if you actually just go ahead and scroll down the data sheet here, you can see that we have here that if they're all down or open, then it's 9600. If 10, it's 19.2. 9 is 38. 9 and 10, which is basically 19.2 plus 38.4. Then we have 1, which is 76, and then 1 and 1, which is 11.5.2. Now, it's also to note here that we have the power wiring details. So the rib, these BACnet ribs are actually full wave devices. So it's really important to understand that if you have full wave and half wave together, if the ground isn't floating, you can let out the magical smoke in some of your controllers. Remember, for us, we actually need to keep in the smoke instead of letting it out. If you let out the smoke, it no longer works. So it does tell you that if you are using this option here, put a diode in between the COM of the devices. Otherwise, you'll want to use either the ground is floating or just 24 volts DC for both the full wave and half wave device. In addition, it does tell you that the device ID is going to fault to the MAC address plus 277. What is 277, or how did they come up with that? Well, that's actually the vendor ID that came from BACnet Testing Laboratories. It's very common for BACnet devices to take their vendor number and then add the MAC address. So, for example, Reliable Controls, I believe, is 7, so that's going to start with 7 out of the gate. If it's Distech, it's going to be like 364, etc. And there are a lot of things you can find here. You can actually go to BACnet Testing Laboratories to find these IDs without any issue. So just know also we need to follow that if this is an end-of-line resistor, end-of-line, you'll need a 120 ohm resistor, at the beginning and the first and last device. But everything else is pretty much the same here. So I've already set up my relay on my test bench here. So I won't go much more into detail on that. But once I've got this all set up, I just need to close this and get into Work Builder or Pro Builder. So now that I'm in JENEsys Pro Builder and I'm connected to my 534, I'm going to go to my BACnet network and I'm actually going to go ahead and hit Discover. So I'm only going to discover what's on my MSTP trunk here. And as this takes a moment to discover, I can go to the job log and we can see that I'm seeing this 277,008 device here. So I can see that this is my rib here. So I'm going to go ahead and just say that this is we'll just say that this is ribs here. So BACnet MSTP rib. And you can't change the device ID here. It's actually done separately. And so instead of this 277.8, I want to change it to 2008. Well, to change the device ID like this, we're going to just select the device and we're going to select device ID. So this is actually going to allow us to write the device object ID to the remote device, and we're going to say 2008. And it'll just take a moment to do. And once that's done, we'll go ahead and hit the refresh tab here, just to go ahead and refresh it to see. Now to bring in some points or to override our two outputs here, we're just going to discover the points here, and just going to hit discover. But we're going to see here that we have output 1 and output 2. And if I drag them out, because they are binary outputs out of the gate, the enabled flag is set to false, so which we're going to set to true. And I'll go ahead and just name this exhaust fan. So this is just assuming that we're using this for some kind of other external control. So we'll just say return fan as well. Now it's to note that if you attempt to write these at priority 16, it may not necessarily work that way. Some BACnet devices have a specific priority that they need to write to, and this would be no exception. So if I were to just go to the AX wire sheet here, and you'll see that these are on by default, I'm going to go ahead and set up a test output here. And I'm going to go ahead and set this to false. Now I'm going to write at input 10. Now input 10 should go ahead and shut these off. Now sometimes what happens is that if a controller or an object is written to at a different priority, for example, these may write at a priority 16. So if they write at a priority 16, by setting the output by default there, it's actually not going to see it. So we need to write to it at a higher priority. But you can see here that my test output actually has them off. And if I set my test output on, I can actually hear them turn on here. But these are if you want to you control these remotely. Obviously, again, this is for more of a fan safety circuit. So there is internal programming that would allow these to turn on based upon any of the binary inputs to close. But that's really it. What I have here, and when you're going to play with these relays, it's going to be the same regardless of which BACnet relay it is. So just know that for the MSTP side, you're going to control it in the same way that you would as another BACnet device. And there you go. That's all I have for today. And tune in next time when we're going to go over the IP relay. Have a great one.